in the vast expanse of our solar system, where planets orbit the sun in a delicate balance and stars twinkle from unimaginable distances, a cosmic drama was about to unfold, one that would capture the imagination of scientists and the public alike. In March 1993, astronomers Eugene and Carolyn Shoemaker, along with David Levy, made an extraordinary discovery. They were scanning the skies, as they often did, searching for celestial objects that might reveal more about our universe. They found a comet, later named Shoemaker-Levy 9, on a collision course with Jupiter. This discovery was not just another entry in their logbooks, it was a momentous find that would soon make headlines around the world. This wasn't just any cometary flyby. This was a celestial rendezvous with catastrophic consequences. The comet, fragmented into multiple pieces, was hurtling towards the largest planet in our solar system. The comet had been captured by Jupiter's immense gravity and was now orbiting the gas giant. Each fragment was on a path that would lead to a dramatic and violent encounter with Jupiter's atmosphere. It was a remarkable find, marking the first time humans would witness a celestial impact of this magnitude. The event promised to provide invaluable data and insights into the dynamics of such collisions. The scientific community was abuzz with anticipation, eager to observe and learn from this unprecedented event. Researchers from around the globe prepared their instruments, ready to capture every possible detail. The discovery of Shoemaker-Levy 9 provided a unique opportunity to study the impact dynamics of celestial bodies. Scientists could now observe firsthand how such a collision would unfold, offering clues about the early solar system and the forces that shaped it. It was a chance to witness the raw power of nature on a grand scale, and scientists were not going to miss it. The collision would be a spectacle of cosmic proportions, a reminder of the dynamic and sometimes violent nature of our universe. As the world watched, the fragments of Shoemaker-Levy 9 plunged into Jupiter, creating massive explosions and leaving scars on the planet's surface that would be visible for months. This event not only deepened our understanding of celestial mechanics, but also underscored the importance of continued observation and study of our cosmic neighborhood. As Shoemaker-Levy 9 orbited closer to Jupiter, the giant planet's immense gravitational forces began to take their toll. In July 1992, during a close approach, Jupiter's gravity ripped the comet apart. It was a testament to the immense tidal forces at play. The once intact comet was now a string of over 20 fragments, each on its own collision course with Jupiter. These fragments, some estimated to be over a mile wide, were like cosmic bullets hurtling towards their target. The stage was set for a celestial spectacle unlike any other. The fragmentation of the comet further heightened the scientific interest in the event. It provided an opportunity to study the composition of comets in greater detail. Each impact would be like a probe, revealing information about the interior of these icy wanderers. From July 16th to 22nd, 1994, the fragments of Shoemaker-Levy 9 collided with Jupiter in a spectacular display of cosmic fireworks. It was a week-long bombardment, each impact releasing energy equivalent to millions of atomic bombs. The largest fragment, Fragment G, struck Jupiter with the force of 6 million megatons of TNT. The impacts created enormous fireballs that rose thousands of kilometers above Jupiter's cloud tops. They left behind dark, Earth-sized scars that lingered for months. The energy released by the impacts was so intense that it heated Jupiter's atmosphere to thousands of degrees Celsius. The sequence of impacts was a mesmerizing spectacle. It was a stark reminder of the immense power of nature and the vulnerability of our planet in the face of cosmic events. Section 4. Eyes on the Solar System. The vast expanse of our solar system holds many secrets, and every so often, an event occurs that captures the attention of the entire world. The world watched in awe as the drama unfolded. People gathered in parks, observatories, and their own backyards, peering through telescopes and watching live broadcasts. It was a moment of collective wonder and curiosity. Telescopes around the globe and in space were trained on Jupiter, capturing every detail of the event. Amateur astronomers and professional scientists alike were united in their quest to witness this rare cosmic phenomenon. The Hubble Space Telescope provided the most stunning images, revealing the full extent of the impacts and their aftermath. These images were not just beautiful, they were invaluable for scientific research, offering a detailed look at the forces at play. The observations from Earth and space provided a wealth of data, allowing scientists to study the composition of the comet. This data was meticulously analyzed in laboratories around the world, leading to new discoveries about the building blocks of our solar system. The dynamics of the impacts were simulated using advanced computer models. These simulations helped scientists understand the immense forces involved and the potential consequences for Jupiter's atmosphere and surface. The atmospheric response of Jupiter was closely monitored. Scientists observed changes in the planet's weather patterns and atmospheric composition, providing insights into how such impacts can alter a planet's environment. It was a pivotal moment in planetary science as it provided unprecedented insights into the processes that shape our solar system. The data collected during this event will be studied for years to come, offering clues about the formation and evolution of planets. The event highlighted the importance of international collaboration in scientific endeavors. Scientists from different countries shared their findings and worked together to piece together the story of this cosmic collision. It was a global effort, with scientists from different countries working together to unravel the mysteries of this cosmic collision. This collaboration not only advanced our understanding of the solar system, but also demonstrated the power of unity in the pursuit of knowledge. Space agencies from around the world contributed their resources and expertise, showcasing the strength of the global scientific community. This event was a testament to what can be achieved when humanity comes together to explore the unknown. As we look to the future, the lessons learned from this event will guide the next generation of space missions and research. The quest to understand our solar system continues, driven by the same spirit of curiosity and collaboration that brought us together for this remarkable event. Section 5. Scars of a Cosmic Encounter. The impacts of Shoemaker-Levy 9 left behind lasting scars on Jupiter's atmosphere. These dark blemishes, some larger than the Earth itself, served as stark reminders of the event. They provided scientists with a unique opportunity to study the dynamics of Jupiter's atmosphere and the processes that govern the formation and evolution of such features. The scars also served as a sobering reminder of the potential threats our own planet faces from space. They highlighted the importance of planetary defense and the need to develop strategies to mitigate the risks posed by near-Earth objects. The study of these scars provided valuable insights into the composition of Jupiter's atmosphere. It also helped scientists understand the processes that transport heat and energy within the gas giant's turbulent atmosphere. Section 6. Jupiter, our cosmic protector. Jupiter, the largest planet in our solar system, plays a crucial role in maintaining the stability and safety of the inner planets, including Earth. The Shoemaker-Levy 9 event in 1994 dramatically highlighted this role. When the comet fragments collided with Jupiter, it was a stark reminder of the planet's function as a cosmic shield. The massive impacts left visible scars on Jupiter's surface, but more importantly, they demonstrated how Jupiter intercepts potential threats. Due to its immense gravity, Jupiter acts as a gravitational vacuum cleaner, attracting and deflecting comets and asteroids that might otherwise pose a threat to Earth and other inner planets. This gravitational force is so powerful that it can alter the trajectories of these objects, either pulling them into its own orbit or flinging them out of the solar system entirely. Without Jupiter's presence, the inner solar system would be a much more hazardous place, with a significantly higher frequency of impacts. The planet's gravitational influence extends far beyond its immediate vicinity, creating a protective barrier that shields the inner planets from a constant barrage of space debris. The giant planet's role in shaping the dynamics of the solar system and influencing the evolution of life on Earth cannot be overstated. Its gravitational pull has helped to stabilize the orbits of the inner planets, ensuring a relatively calm and predictable environment in which life could develop and thrive. Jupiter's gravitational influence extends far beyond its immediate vicinity. It not only affects the orbits of nearby objects, but also has a profound impact on the overall structure and behavior of the solar system. It affects the orbits of comets and asteroids in the Kuiper belt and the Oort cloud, shaping the distribution of these icy bodies in the outer reaches of our solar system. By influencing the paths of these distant objects, Jupiter helps to maintain the delicate balance of our cosmic neighborhood, ensuring that the inner planets remain relatively safe from catastrophic impacts.